Okay, so this is what we solved yesterday, right? Using graph method. Okay, and this is our constraints. So these are our constraints. So what we'll do in Excel, we'll talk about X and we talk about Y, and this is your value, right? And this is greater or less, right? The sign. So what we said is 1x plus 1y is less than or equal to 10, right? Okay. And then second thing is 1 and 2y. 1, 2y is less than equal to 15. 4, 3, 25. 25. 4, 3 less than equal to 25. Okay, so these are constraint. Okay, and we are okay. What is our objective function? 750,000, right? So 750, and this is 1,000, right? We want to maximize this. So let's assume that we make only one x and only one y. Value of x and y is only 1. Okay. So what is the total profit? Total profit is 1 into 750 plus 1 into 1,000. Right? So this is what you want to maximize. Okay, so how do we perform this? So we need a solver add-in. Okay, we need to solve using solver. Where do you get solver? So see, solver, you can see it in your Excel. Okay, if you don't find it, if it is not there in your Excel, you need to go to File, Options, okay, and add-ins. If you go to add-ins, okay, you go to Excel add-ins and you say okay. Okay, you will see solver here. You have other things. Okay, solver will be there. So it is checked. That's why it is appearing in my Excel. Okay, if it is not there, okay, in your Excel, probably this is not checked. So you go and check this box. When you check this box and you say okay, it would appear here. So you have to start solver. Okay, solver is used to solve your maximization minimization problem. So set objective. What is the objective? Objective is this, isn't it? F12 is objective. What is the objective purpose? To maximize, right? So you can do maximize, minimize. You can even do using Excel value of. Value of means if you want exactly a particular value. If you want exactly, say you want 10 lakh profit, exact 10 lakh profit. So you can say value of and you put 10 lakh, right? But in our case, it is maximize. We want to maximize as much as possible. But changing cell, by which cell you need to change? Okay. Now we need to change this one and this one. Correct? We need to change this one and this one. Okay. There's something wrong here. Okay. Not so wrong. Something is incomplete. Okay. Let's first do that and then we'll come back to it. Okay. So this is 1 and 1, right? Assumption. Now, how many, how will, no, what are these values here? Okay, this is nothing but this one, isn't it? 1 time of x. So if this increases, this should also increase, right? This is again this, right? And this is your twice of this. That means if you increase this, this will also increase. This is 4 times of this, right? And this is your 3 times of this, right? And let's make it full value. Okay, we'll make it 1,000. This is 10,000. This is 15,000, and this is 25,000. Okay. So now let's go to solver. So solver F12 maximize by changing F11 to G11. F11 to G11. subject to constraints. So we can add the constraint here. Okay, so let's add constraint one by one. First constraint is that this value has to be less than equal to, right? This value. Add. This value has to be less than equal to this value. Now, again, how do you calculate this value? You have to add them together, isn't it? So again, I made a mistake here. Not made a mistake. We can always go back. So instead of, okay, doing this here, okay, let's add this sum. So it is actually sum has to be less than 10,000, right? So right now your memory chip, you're using two memory. If you want to make one laptop and one desktop, this is your desktop, this is laptop, you need memory chip, this is your hard disk chip, this is your labor time, right? So you have to add them together, right? So total 7 should be less than 25,000. Correct? Now let's go back again to solve it. Okay, so now you see instead of constraint, okay, we'll remove it, okay, delete it, and we will start adding again. So this 2 should be less than equal to 10,000. Okay, this 3 should be equal to less than 15,000. And this 7 should be less than equal to 25,000. Okay, so you have the objective functions, value, and constraint all together. And now you solve it. So see, it has given us the solution. Okay, so it says you have to make 1,000 of X and 7,000 of Y. X 1,000 of laptop and 7,000 of desktop. Okay, and if you want the answer to remain, you say okay, otherwise it will reset it to the original value. Say okay. So what it says is you need to make 1,000 laptop and 7,000 desktops. Okay, to get, okay, this is your maximum profit. It's not possible to make profit more than this. Okay, it says it's not possible to make profit more than this. Okay, so this is how we could solve using Excel. Yes or no? Any questions so far? No?
No, sir.
Perfect. Okay. So this is Excel based. Now let's go and solve the same problem using our SciPy. Okay. So equality problems will be solved by NumPy, and inequality problems will be solved by SciPy. This is inequality problem, isn't it? It's greater than or less than or equal to. Okay. So of course, to read the data, we need to import NumPy. We'll import NumPy to read the data. Then to perform optimization, we need to import. Okay, so from SciPy dot optimize, you have something called as optimize. You have to import linear programming, linprog. You have to import minimize, okay, and say linear constraint. Okay, now you see here, okay, here your problem can be minimize or maximize actual problem, but the way it has to be implemented, Okay, it has only way to implement is minimize. Okay, it only knows how to minimize it. It doesn't know how to maximize it. Okay, so there's a function for minimize it. So if it is to minimize it, how do you minimize it? Okay, how can we convert maximization problem using minimization? Can we convert maximize to minimize? Answer is yes, you can convert. Okay, so how do you convert? Okay,
Take other stuff, take them to right side instead of left side.
right, correct. So, or you can do minus sign.
Okay.
Minus with minus one, sir.
Okay, so yes, so let's say if I tell you 5 is greater than 3, correct? So if I tell you 5 is greater than 3, okay, then if you multiply with minus both the side, what happens? If you minus both the side, multiply with minus, what happens? Now which is greater? I multiplied both the side with minus. Now which is greater? Is minus 5 greater or minus 3 greater?
Minus 3 greater.
Yes, so sign will change automatically. Okay, so if you multiply with minus, sign changes automatically, right? So that means if you have to maximize it, okay, and if you multiply with minus, it becomes minimization problem. If you want to minimize it and if you multiply with minus, it becomes so. So there we took 750 plus 1000 as profit. So if you multiply with minus 750 and minus 1000, it becomes a minimization problem. Okay. So we have to convert into minimize. Okay. So let's see how we can do it. So let's say, okay, your L becomes number of laptops to make. Okay, we'll start with 1 first. And desktop is 1. Okay, it is your number of desktops. Okay, and profit per laptop is 750 rupees, correct? And profit per desktop is 1000. Okay, so what is total profit? Okay, so total profit, okay, is L into profit of L, correct, plus D into profit of D, right? So this is your total profit. Now this is to maximize, right? So our objective, okay, objective, okay, is to, okay, so what we'll do is objective is we have to pass 2 variables as a set. So your objective is okay, maximize. Okay, instead what I'll do is I'll put minus here. Minus here. So this becomes minimization problem. Okay, this becomes minimization problem, right? Okay, now we have to build our constraints. Let's copy the constraints that we had. Okay, so constraint. Okay, so this is your left side constraint. Okay, so left side constraint, we'll put it as so this is like 1 1 1 2 as a matrix. We'll use NumPy. So I'm going to say LHS left side constraint equal to 1 comma 1. Okay, 1 comma 2. Okay, 4 comma 3. Right? So this is your left side set, right? Correct? Now we have to create our right side equality. Okay, constraint is on the left side, that's why we say LHS constraint, and this is your RHS. Okay, value. Okay, RHS value is 10. Okay, or you can say 10,000. Okay, 15,000, then 25,000. Right? And okay, so this is the constraint and the value that your constraint will have. Okay, next is to indicate the boundary. Okay, what is the values of these x and y? Okay, so you can define maximum and minimize value. Okay, your minimum value of this is going to be 0, isn't it? Minimum that we have to find ultimately L and D, right? So your L and D has to be minimum 0. Right? It can't be minus 1, right? It cannot be less than 0. Okay, so minimum it can go is 0. So I'm going to say here, okay, sorry. I'm going to say here your bound equal to, okay, now your value is going to be minimum 0, right? And maximum it can go is infinity. So this is how we write infinity in NumPy. Okay, so 0 to infinity, this is your first value, right? Second value, which is D, will also be 0 to infinity. Okay, so I'm going to copy this and paste it. Okay, now I have to optimize. Optimize solution equal to your linear prog, and here you have to give each of those values. So see here, C, okay, looks like, okay, see, is deprecated and removed in SciPy. Okay, in future version is going to be removed, but okay, we can actually use this for now. I don't think it's problem here. So optimize, now you have to give values. So C is the objective function. Okay, so what is your objective value? Objective value is the list of values, right? So this is your objective. So C is your objective, followed by, okay, followed by your what do you call the A upper bound. Okay, so A upper bound, okay, is given by your LHS constraint. Okay, LHS constraint. Okay, and this is followed by your the right side value. Okay, so that is B upper bound. See, if they were equal to, then you would have used equality. but this is bound. Okay, so that's why we are using this, and we don't have to say like greater than less than because we are using minimize. So it knows that value has to be more or less. Okay, and if you had equality, you would have used equality there. Okay. Okay. Now a bound is done. Now let's say now we have to add a bound is what? Right hand side value, right? So objective function right side, left side, and now finally the bound, right? What is your bound? So bounds equal to B and D. And we have to say method. Okay. Method we are going to use is called it's called reverse simplex. Okay, or revised simplex rather. Okay, revised simplex. That's it. Okay, and if your answer is correct, you will get true. So I'm going to say if optimize solution. Okay, if optimize solution, then you can print the value here. Okay, you can print okay optimize solution dot okay x of 0 is your first value. Okay, x of 1 will be your second value if you have. So this will give you, let's run it and see, this should give you the values that SciPy calculates. Okay, so no, I give 0 only, right? That's why it's giving. Okay, it should be 1, right? Second value. So 1,000 and 7,000. This is exactly the same thing that we got in Excel also, isn't it? Okay. And if you want to know the total profit, the final output, print total profit equal to, you have to say optimize solution dot fun. Okay. And when you run it, you see, so because we had minimized, right? So we have to multiply this with -1, convert it back into maximize. Okay, so this is your profit. Same thing like what we did there. Right? So that's how you can use SciPy to perform inequality problems.
Sir, in this, how can we declare by user defined for the
User-
LHS constants?
Yeah. So see, so you have to take the input, right? And then this is what? This is just list of list.
Yeah, user defined, I'm asking.
You said input, right?
Yes, sir.
Huh. Take input values and convert into list.
No, sir. In the code, we are giving all the values, no, sir.
Arey Baba, you don't know how to convert into list?
Yeah, I know.
Then see, these are the values that you need to read from the user, correct?
Yeah,
Read it and then put it in the list. I didn't get your question. You want this to be user input value, right?
yeah, in the console.
Correct. So you have to ask for input. Read the values here.
Okay.
Okay, read the values. Now,
By list, we need to read, no, sir.
correct. And so list how many rows and how many columns. That's the question. Number of rows will be okay depending upon number of constraints that you have. Okay, so it's a list, multi-dimensional list, right? So number of rows will be same as the number of constraint, and number of columns will be same as the number of variables. So laptop and desktop, 2 variables. So column will be 2. Okay, how many constraints? So you keep asking, do you have more constraint? Do you have more constraint? Yes. Then keep reading and keep appending to the list. Okay. And so you have to form two lists, one for the left side and one for the right side. Did you understand or not?
Yes, sir, understood.
So here I can go and say while true. Okay. Print or input. Do you have more constraints? Okay. So let's say you give y, then it goes up. Okay. If ch not equal to y, you break the loop. Fine. Now here I'm going to say LHS constraints. Okay. Equal to empty list. Here you ask the user. Say L1 equal to 1, L2 equal to 2. Let's say, we know there are two variables, so we're going to read it like this. Input, enter the value for X1 or notebook. Constraint 1, right? You can say constraint 1. And then int of, right? You convert into int of. So you get this. Okay. Now you convert this as a list. Okay. So your LHS constraint dot append, you get L1 comma L2. Okay, this is a string, right? Character. So it will be in quotation. Now when you print it, okay, print LHS constraint equal to LHS, right? Or similarly, you can do enter the value for notebook, desktop, and here you can say Y1, Y1, input the value for Y or the right side, right? And you can create RHS value, okay, equal to this. And then you say here, so this becomes another list, your RHS val dot append. Here you'll have only Y1, right? So your LHS constraint is this. Okay, your right side value, right side values is correct. So now when you run it, so notebook 1, 1. Okay, y is 10,000, 1,000, 10,000. Okay, then you have 1. Oops. Do you want to come? Sorry, I missed it. Okay, so notebook 1, desktop 1, total 10,000. Do you want to continue? Yes. Okay, your value for notebook in second case is 1 and desktop is 2. And this is 15,000. Okay, you continue? Yes. This is 4 and this is 3. Total is 25,000. Right? No. Yes or no? Same thing we made, right? Yes? Aviram?
Yes, sir, understood.
Yes. So this is how you can make dynamic. It's about making the list only, isn't it? Okay. Okay. So with that, we finish our SciPy. Okay. We'll move to pandas. Okay. And why do we use pandas? What's the purpose of using pandas? Pandas is used to analyze or, you know, work with data frames. Okay. So what is data frame? Data frame is, okay. Let me move this to some other file. Okay, I'm going to call it P1. Okay. So pandas provides mechanism to handle data frame. Data frame is a way to read, okay, data in table, in table format. That is row and column format. Okay. And when you're reading, let's say a CSV file or Excel file or even database file, okay, this is how you will read it, right? You will read it like a data frame only. Okay. We can create our own data frame as well. Okay. So to work with it, we have to say import pandas. And we say import pandas as PD. Okay. Now you can create a empty data frame. So data frame 1 equal to PD dot data frame. Okay, and this will create an empty data frame. Okay, if you want to add data, okay, so you can give data. So I can say data equal to, and we'll give it in. Okay, now each of these will have, like, first value will be value in the first column. Okay, so let's say I give here as Sachin. Okay, and here I give it as, say, Virat. Okay, here I give as, let's say, Rohit, right? And then let's say you give age. Okay. So the first value, okay, of this list will go as first column. Second value will go to second column. Okay. So now we have to convert this data into data frame, right? So we can say this as, let's say we'll call here data frame, df1 equal to data frame, and we'll pass the data here. Okay. Now you print data frame df1. You see what it does? Automatically it adds numbers for rows and column. So this is your first column, right? So it is denoted by number 0. This is your second column. Okay, so this is denoted by 1. First row 0. Now you can name row also, you can name column also. Okay, now when you have small data set to handle, you can name row also, but you know that, right? Row can run into thousands, then doesn't make sense to name a row. Okay, but initially you can name a row, right? So here, okay, let's say you have um, uh, you want to name the column, right? So see, by default, Python will give name to row and column both. Okay, but you can choose your own row and name. Okay. Okay. So now let's say I want to give column name. So how do I give column name? I'll say comma columns equal to, and how many columns it has? It has 2 columns, right? So we will give a list with 2 values. Let's say name, comma, age. Oops, sorry, where am I giving? This is in the, when you're defining the data frame. Okay. Now when you run it, you see name and age has been assigned to these columns. Okay. So yes, so this is how data frame looks like. Tomorrow we'll read a CSV file and we'll try to work with CSV file using data frame. Okay, sounds good. So we'll stop here for today. Yeah.
So means pandas is to represent the data into the tabular format. Huh?
Correct. Correct.
Only that operation is